Good morning, my YouTube viewers. In this particular video, we're still going to be talking about experimental design, but we're going to be using an A/B test as part of the experimental design, and it's going to be a simplified ABS to talk about some marketing features. And then so the practice question is, use ABS to optimize product features. And what we're going to do is we're going to write a Python program to perform this A/B test. And before we make the Python program, what we have to do is we have to import the libraries that we're going to need to actually execute the program. And the first library that we're going to import is NumPy as NP, being a numeric library that also creates NumPy arrays. And then we're going to import matplotlib.pyplot as PLT, which is a visualization library. And from scipy.stats, we're going to import chi2 contingency. So scipy is Python's scientific library, and stats is a statistical module within scipy, and chi2 contingency is the test that we're going to perform for this sample question. So the first thing we're going to do is we're going to simulate the A/B testing data. So in that regard, what we're going to do is we're going to set our seed, and you need to set the seed to make sure that every time you run the program, all the variables are set up to the same data. And then so we set our seed to np.random.seed and any number that you want in between the brackets. And again, you set the seed so every time you run the program, the variables will be initialized to the same values, and the program will run the same every time you run it. So we're going to define the variable total users, which is 1,000. So now we're going to set up feature A data. So feature A data is group A users equals total users floor 2. So that's going to be 500. And group A conversions equals np.random.binomial brackets group A users, comma 0.18. So binomial distribution is a distribution where you have only two outputs. You have either a 1 or a 0, or it could be a true or a false. It could be a yes or a no. It could be an on or an off, but you only have two outputs in the binomial distribution. And you have an 18% conversion rate for feature A. And then for feature B, we're going to have group B users equals total users floor 2, so that's 500. Group B users equals np.random.binomial brackets group B users, comma 0.25. So that's a 25% conversion rate for feature B. So we're going to create a contingency table for the chi-square test, and we're going to create a NumPy array to do that. So data equals NP array, and then the first row is going to be group A conversions, comma group A users minus group A conversions, and that's conversions and non-conversions for feature A. And the second row is going to be group B conversions, comma group B users minus group B conversions, and that's conversions and non-conversions for feature B. We're going to perform a chi-square test on this data. So chi-square, comma pi, comma underscore equals chi-square contingency data. And so basically what we're going to use in the program is chi-square and then p, which is your p-value. And the other two values that are part of this function won't be used, and that's why they use the underscore. So now we're going to print the results. We're going to print A/B testing results. We're going to print feature A conversion rate, feature B conversion rate, chi-square statistic, and your p-value. So we go over here to the bottom of the cell. So A/B testing rates is feature A conversion rates is 17.2, and we set it up for 18. And feature B conversion rate is 25.4, and we set it up for 25. Chi-square test statistic is 9.545, and the p-value is 0.002. And so since the p-value is less than 0.05, that means you have to accept the alternate hypothesis. So basically what has happened is the null hypothesis is there's no significant difference between feature A and feature B, and the alternate hypothesis is there is a significant difference. So we have to go with the alternate hypothesis because the p-value is less than 0.05. And so now here we have the code for if p is less than 0.05, print the difference in conversion rates is statistically significant, which is what it is. So now we're going to visualize the data onto the chart, and it says labels is a list of converted and did not convert. Group A data equals Group A conversions, comma, Group A users minus Group A conversions. Group B data equals Group B conversions, comma, Group B users minus Group B conversions. X equals np.arrange, bracket, len labels, and that's 2. And width equals 0.035. So now we're going to create a bar chart, plt.figure, brackets, fig size equals 6,4, plt.bar, brackets, x minus width divided by 2, comma, group A data, comma, width, comma, label equals feature A, comma, color equals blue, comma, alpha equals 0.7, and plt.bar, brackets, x plus width divided by 2, comma, group B data, comma, width, comma, label equals feature B, comma, color equals orange, alpha equals 0.7. And now we add our labels and annotations. The title is A/B testing, feature A versus feature B. The X label is outcome. The Y label is number of users. X ticks is X, comma, labels. You get a legend, and the grid is axis equals Y, comma, line style equals dash, comma, alpha equals 0.7. And now what we're going to do is we're going to insert some code into the chart to place the numbers on top of the bars. And then plt.type layout, brackets, and plt.show. So this is the chart that has been made using Matplotlib. And you can say feature A is blue and feature B is orange. So converted, blue had 86. So feature A had 86 conversions, and feature B had 127 conversions. And feature A 414 didn't convert, and feature B 373 didn't convert. So you're going to say that feature B performed better than feature A. So feature B is what you're going to want to go with. So that concludes this video. The next video we're going to be covering some more statistical subjects. So I hope you decide to watch it.